Looks like I'm up. Greetings to you, viewer from across the tubes. It is I, Gnarly Quack. I am back working on my TOML parser in Python. Not much to say, I guess. I guess I'll just get into it. I was here. I had pretty much finished up the Lexor, and was on to the parser, although we're going to have to circle back to the Lexor. I guess I'm going to have to get my virtual environment here up. Oh, that one didn't work. But I'm not 100% sure where I left off. I guess we'll soon find out. And what do I have? Make test, I think? Yeah, okay, we got some tests going. Let me pull up my documentation. I'm not sure if we're going to need the grammar anymore, but I guess I might as well pull it up. Here's the spec, here's the grammar, and I guess I'll get into it. So I think we just have this test file here. Let's see. Oh, you know what I forgot to do? Forgot to reboot my computer to try and get this to go away. Oh well. Just, I guess I'll just have to live through it. So it looks like what we have next is date times. And it looks like we more or less have all this stuff working. So I guess that's where we will start. And that's right, I was actually walking through my examples here because I've been using the spec here sort of to provide examples to drive this stuff. Trying to see what I've done here. Well, obviously I'll have to clear some of this stuff, clean some of this stuff up, but what I was trying to say is I've just been using the examples here in the spec to sort of drive my own tests and examples. So that is what we will do. I guess I never even tested Zulu, huh? Well, that'll be interesting. So here we go. I guess we'll start with this. And what was my pattern here? I guess what we expect is, well, let's see. I'm going to have to make these date times manually, I guess. So we're at ODT1, something there. ODT2, something there. Something there, and ODT4, something there. Nothing for the error, so then we're just gonna assert a result here. Guess I better copy this in here. And then we're gonna have to get this import date time. And we're gonna have to make these. Dates. So let's go here, and we want date time. So I guess this is gonna be year, which is 1979. 5:27. Hour is going to be 7. Minutes going to be 32. Seconds is going to be 0. And then because this is obnoxious, we're going to have to create a time zone info here. I guess I have to probably do that. And I think it's just called time zone. I guess what do we have? time zone, and I believe that is constructed from a delta or time delta. So I kind of almost just want to import these, but whatever, is going to be a date time. And this is going to be, oh, you know what? I guess, well, I don't know. Let's just do this. This is going to be hours equals 0 and minutes equals 0. So that is going to be that. Oh, wait a second. Oh, this was just an example with the space in there. I guess I never tested that. Oops. Guess we're just inking all of that. All right, so this is 1979, 05, 27, 0, 32, 0, and this is going to be -7. This is going to be 1979, 5, 27, 0, 32. I think microseconds was the next option. Yeah. And then again, this is going to be, I guess in this case, I don't actually need to specify the time zone, but that is going to also be -7. Or I guess one way I could do this is just, excuse me. I guess I could just stick the minus in front of here too. And this is 527, 732. Just the same as that. So now if we make our tests, it's not what I expected. Well, obviously we have a, oh, wait. We have a what? Oh, I guess we just want an empty time zone. Let's see. Leading zeros and use an OO. All right. So does that mean I just needed to get rid of these zeros? Oh, 5. I guess that's what it's complaining about. Okay. Handle token type year. Oh, this must be in the parser. Okay. That's right, which makes sense because we have not implemented that yet. So we're here on line 91. So let's see. So token type is actually, I think there's just going to be year, I guess. We're going to parse a date. I guess we'll put that after parse decimal. And actually, this will be where having the grammar, I guess will be nice. So let's see here. Parse date. So in any case, we're going to have a full date. So I guess what we'll have is we'll have hour equals actually we want to eat that token. Did I do that right? I feel like I typed an hour. Okay. And then hour is going to be the value. Then we're going to I think I just called that. No, I called it minus. Then we're going to have minutes. Oops. And then minutes is going to be that passed to an int. This is going to be the same thing. I believe, so full date, that will be that. So now we may have a time delimiter. Oops. Okay, if oops, we're going to want to eat that. And we're going to want to parse the time. Now this will, I guess, give us back a time. Right, because we're returning these. So then we'll do that. Then, let's see here. So then we either have a full time or a partial time. A partial time is what we're going to parse in the time. But the full time, which is we can only have here from this offset date time, is going to have this time offset, which can either be Zulu or this plus minus. I believe that's required. Time hour. But what we've done is we've normalized Zulu to plus minus 0. In fact, let me. Guess it shouldn't really matter, but yeah, we put plus 0 in there. I guess, right, it could be either one of these, plus token type minus, then we're going to do sign equals and we're going to have hour equals actually, I want to make this token. Then we're going to eat a token. Eat this colon. And minute is going to be and minutes is going to do that. So then we want to set the result equals I think I have date time imported in here. I do. I guess the offset, let's set time zone equals, actually, we'll go offset equals, and what was our signature here again? Hours equals hour. Minutes equals minute. If sign dot type token type minus, then we're going to set offset. Boy. Just reverse that. And then I guess we'll do time zone equals and right, that was just a offset. And now what we want to do is we want to do the state time. Which is going to be year, or this is a date, yeah. Year, month, day. I don't know why I always want to get my dates and times mixed up, but I do. I do. So what do we get? We get time there. So we're gonna have year, month, day, time, that hour. I guess I should look to see what this has just to confirm this. Yeah, hour, time dot. Where are we here? Oh, I guess I wanted this over here. Hour, was it min? Hour, minute, second. So year, month, day, hour, minute, second, microsecond, and then time zone. Otherwise, our result is just going to be out the time zone. Or actually, you know what I guess I can do is right, what's the default? None. So that's what I guess I'll do. So then I'll just bump this out. And if we did not get this time, right, we're going to have just a date. Otherwise, our result is going to equal date, time, date, and that's just year, month, day, I believe. I guess I'll double check that just to be sure. Yeah, year, month, day. And then we will return this result. Now, we will probably still crash here, or fail our test, I should say, because, well, because of that, which is not what I was expecting. Sorry, 148. I wonder why we don't have that token. Offset date time set. Well, I guess there's only one thing for it, but to Let's break at why is this acting like oh. And what line do we think we're at? 145. All right, so let's see what our see what we got for tokens. Ooh, we got a lot. Got a year. Oh, I did call it a dash. Oh. I made two separate ones? Okay, well, I did not mean to do that. So let's just see where that blows up on us. Actually, I guess we don't really need to do that. I'm just going to actually have the Lexer open. Oh, there it is. All right, so minus. Guess that's it. So now we got the expected blow up. So we're going to have parse date or parse time. So this is going to look very similar. Let's just yank that. So except this time instead of a minus, we're going to get this colon. This is going to be a minute. Just bump this up. And then if then we're going to eat that period. And then microseconds is going to be, I think I called this fraction. And that's actually going to be token. Otherwise, our microseconds are going to be 0. And then our result is going to be this time, which is going to be hour, minute, second, microsecond. And we'll return that. I guess we'll just knock out some of that white space there. Okay, and we are passing that. So I think that's probably actually going to take care of all our date time examples. Let's just go through here. So we have a local date time. I believe that's okay. I'm kind of inclined to just recopy this, but oh, that's right. I put that in there because I want to make sure we were handling microseconds okay. Yeah, that'll still work. So then our result here, let's just take that. We only have 2 of them, so I can delete those. Oops, that's not what I wanted. It's local date time, so we're going to have 1979, 5/27, 7/32. Oops. And then this is going to be 1979, 5/27, 0/32, 0. Should be that. Always forget to put my colons for some reason. Okay. Local date. Oh. Set this one local date. This will be so 5/27. That will be that, I believe. Oh. Past that. Local time. I guess I have local time in here twice. I don't know what I'm doing. Oops. This will be, what is this here? I guess I just, for some reason, had that in there twice for no good reason. 7/32, okay, so then $7.32. And then we want to insert the result there. Oh, that's right. I don't have this underscored here. Oh. That's right, because where was that? 93. This will get hit up here. And that date, this will be time. This read something there. Yeah. Okay. So I guess that's it for that. We are on to arrays. So I have a feeling, actually, we're going to want to comment that out because we don't have inline tables. We're not parsing inline tables yet, but I think everything else we should be in fine fettle. I guess we'll just yank this for the moment. Might make things a little easier. Something doesn't quite look right there, but oh well. Don't need that. This is trying to be too helpful. Actually, so let's see. This is going to be 1, 2, 3. Red, yellow, green. That will still be that. That will be that. I think that will be that. Kind of shudder to think what's going to happen here. This is just going to be 1, 2. So I think we look okay there. Okay. So we were back in our parse error. This is 95. So we're going to return this array. Let's pull our grammar up again for arrays. And let me just make sure there aren't any gotchas here. I don't think there are. Just that we have this potentially terminating comma, I guess, is kind of the only thing. So, kind of feel like I wanna put this up here. So we're going to eat. Oops. So that'll be a result. We're going to want to eat. We call that a left bracket, I believe. So something like, well, peak token iterator that type does not equal token type r bracket. We're going to want to write, it's just a value. What do we got here? A value. So we're going to parse a value. That'll be our iterator. Actually, I think I want to do this a little bit differently. We're going to do parsing equals true. While parsing, token is going to be, going to be that. Token type equals, let me think about this. Actually, yeah, maybe that was better the same way. Actually, let me just undo all that. Right, if peak token iterator.type equals token type, comma, we'll eat that token. Otherwise, if we don't get a comma, we should be done. Otherwise, break. And then we want to eat that closing bracket. And that should be, yeah, an R bracket. And then we want to return the result. Oh, you know what? We're going to have value equals that. And then we're going to append the value. So if we have another comma, we eat it. And we can have a trailing comma, so this is fine, right? Because then we'll just break out. Otherwise, we should be done, and we're done. So let's see what happens. We pass, it looks like. So that's dope. Is that our only array example? So I'm going to skip down to inline tables, I think. Yeah. Because inline tables, work very similar to arrays, but the other tables that we have are going to be going to start introducing a little bit more complex logic into the parser. So here we're going to have name. Yeah, that was right. First equals Tom. Last is Preston Warner. Point is going to be x is 1 and y is 2. And then animal type. Ooh, we're going to have dotted keys in here. Have we not dealt with dotted keys yet? Not sure. Got a lot of tests going here, I guess. Yeah, we do. Anyway. Where are we? Uh-oh. So this is actually going to create a new table. And this is going to be name is pug. And then we want to do self. We're going to want to assert that is what we got. And we have our left brace. So that was on 97. And this is going to go to that. Because I think we'll have handled everything then. And this is going to go to inline table. So we'll put that, I don't know, this doesn't matter. Guess we'll keep these in like nominally alphabetical order. So we want to eat a token, which is an iterator, token type, left brace. In this case, result is going to be a table. Now, in this case, we cannot have a trailing comma. So I feel like, right, it's, we have that. Inline table key vowels, so that is a key val. I suppose it doesn't really matter, right? Our lexer, I mean, I kind of feel like I want the trailing so we should catch that in the lexer. I feel like I want my logic in the parser just to back me up on that. So I think I'll do what I was thinking about doing the last time, which is parsing equals true. Actually, here's what we'll do. We'll do parsing equals right. So then while we're parsing, we will I guess I got to see how this looks. So what do we get? We pull off the root table. Which is not what we want, right? I guess what we'll do is so I have this table state because I know we're going to need it later. But maybe we don't need that for parse keyval. I feel like we don't. I don't know. Let's just do. What happens if we do that? And do I have root anywhere else in there? Does not look like it. So what we'll do is, this is why having tests with the parser helps. So we'll parse a keyval in this result. And then that should eat that. So if right, so then if we peek this token, and that is a, then we want to eat this token. Otherwise, we are no longer parsing. And then down here at the bottom, we're going to want to eat this right brace. And return that result. So I'm a little bit curious how that works. But we do... this is going to be root, I guess, at the moment. Yeah. That is probably going to change, but I think that might actually work right now. And it appears to work, so... I don't know. Let's just... Oops. Let's just make sure we get a failure that we expect. All right. So this is telling us we expected an animal type name empty string. We actually got that. And actually that reminds me, I think I wanted to reverse how I'm doing this. I think I want to do... I want to do that. I think I want to put what we expect. First, so did I fix that? So that'll just put, we expected pug and we got, or no, we actually got pug. We expected, I'll probably just confuse myself even more than I already was, but I've done it. I'm committed to it. So now we gotta get this working. Yep, this is an array. So I guess we'll probably, oh, well, whatever. So I don't think I want to do that. What is this doing? Okay, that is what I wanted to do. And then we'll do this. Oops. Guess that's what I'll pass now. Nope. Forgot that. Guess for good measure, I could stick that in there. So what happened? I need to I need to uncomment that in my TOML as well. Okay, and now we're back in good shape. So I think that is all the easy use cases. But I guess I should make sure there are no more inline table examples here. So I guess we need to test that because I don't believe I have Yeah, I didn't actually test that before because this should be, I guess, test inline tables are closed. So what this is saying is, oh, well, this is obnoxious because, well, it probably doesn't really matter. So our TOML is going to be, and here what we'll do is we'll just comment that out for the moment. And then type that edible equals false. That should be invalid. You know, I keep saying to myself, I'm done typing this out. And I always catch myself typing it out. So let me just do that. In this case, we will comment that out. I gotta close that. So in this case, that's going to be a new error. We're saying that is line 3, and I guess this is going to be character 1, and I forget what it is, something like key type. Well, let's just put something that we hope is obviously wrong and won't pass, just so we can see what we get. Oh, and so yeah, see, we're getting no errors. We are instead just adding that in there. So what do I have up here? I have so in order for me to handle this, the last time I did this, I had a meta value, which I guess I may just call meta info this time. And what I want to do is and so what we can do is we can do the token that defines it, and then we're going to need to take some flags here. At this moment, I guess the flag we're going to take is inline. And so in our state, in our table state, we're also going to have a meta info, which is going to be a meta info I guess this will be none. Actually, instead of inline, what I'll do is I'll call that closed, and this will be false. We're also going to want, I think, we're going to want to keep the value, I believe. So maybe let's just pass that in there right away. And I like doing it this way. So there's two ways we could do this. We could actually keep the meta information here in like, so this root, this is like the root table. This is the table that, this is going to be what we end up returning after we parse, at least for now. So we could either keep the meta information sort of in this table, but then we'd have to, when we were done with the parsing, we'd have to then walk through that table again and reconstruct the actual, just the value that we're going to return to everybody. And I don't know, considering what I want to do, maybe that's the right way to do it, but I'll change it if I need to. But in this case, I'm keeping the meta information separate out of the table. So when we're done, we just return this, and then this just gets tossed away. But in the meantime, we'll use this meta information to well, keep track of what we need to keep track for parsing. So we'll do that. Now, what we want, so we've set that up. Here when we create our state, that's all set already. So we pass this into parse expression. And then, well, we're not actually doing parse table and parse array table yet. At the moment, we're going to want to pass this meta info in. So this is going to get meta info. And we're going to, so we get the key. And if we get a period, right, this is where we start, but let's skip this for now. So we're going to get a value back. So if the key value is not in the table, we just add the value. And then we're going to do meta info dot sub value equals, this is going to be meta info. It is going to be this key. It's going to be false because this is not closed, and we're going to use that value. Otherwise, I think that's all we need there. But now up here, right, if the key is not in the table, then we're going to do the same sort of thing here. We're going to do meta info. This is also not closed, right? This is implicitly defined. And actually, we're going to like synthesize this value. So let's do this. Let's do value, and let's do value here. Then we pull the value out, and we're also, right, we pull out whatever that is, and we're also going to want to update the meta info. Wait a second. We're actually going to want to set this to the key value. And down here too. Oops. Because we're going to want to pull out basically the new sub value. So, now if the table is not a dictionary, then that is key redefinition. And actually, right, I think this is going to be the same thing. And what we may do is we may... Actually, here's what we'll do. Because what I do in this case, right, is I synthesize basically a fake value so that we can kind of keep going. But in this next case, I don't think I am going to synthesize a fake value. Now, the problem with that is we could get false errors. So maybe I do want to do that. I guess it's hard to tell. So in this case, we're just basically trying to explicitly overwrite a value that was already set. Which we're not allowed to do. And what is the test case that is it defined maybe? Yeah. So like here, 3, 1, and then here, right? 7, 1, or no, wait, 3, 1, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So here we're saying, right, Apple has already been defined up here. So that is why I just synthesized like a fake thing. But what could we alternatively do? We could just skip that. And maybe that's what we want to do. We just kind of want to... I don't know. It's hard to tell. I guess it's hard to tell unless we have like a test case. Because, right, so what we were happening here is we were erroneously setting edible. But we're not allowed to do that because inline tables are closed. But if we just say, oh, okay, that's fine, right? If here, let's say edible is already in there, right? The error, and then we try and again set edible, right? The error is that not necessarily that we're trying to overwrite edible. The error is that type is closed, right? But if we just say go ahead and don't like synthesize this false table, when you come back down here, we'll get another error. Like we'll already have this error about type being redefined, and then we'll also get another error saying edible's been redefined. So I guess maybe we do just want to do a thing, or we could just basically bug out. Well, like, because I feel like we still want to parse the value, because there could still be errors or something in the value itself, and assuming there was something that they want to do. So yeah, we'll just do this for now. So if this is not a dictionary, or meta info is closed, then we'll do that. So let's see what we get. And inline is not defined. I changed one thing without changing it elsewhere. What did I call this? Subvet. Oh, yeah, and I broke a bunch of stuff, it looks like. I have 6 errors now. So why isn't this showing the full error message? I suppose some of the errors we have is now we're calling this from. So we actually got this. We expected none. I guess we're saying fruit was already defined. Oh. So that should be fine. Why do we think that's not fine? So where are we defining? So we're never actually ever setting this true anywhere, right? Well, I guess we best just debug this. So we are in let's break here. Okay, so now let's break in source, TOML parser at 66 there. So what do we have for key? We got fruit. We eat that token. Wait a minute, what happened there? I guess I skipped ahead. So we went from 67. Okay, we are in. Okay, so if it is not in the table, what do we have for table here? And what do we have for meta info? I guess probably going to want to let's get a rupper for this. This will just do this, and value equals that. And actually we're going to want this to be a representation and same as that. So where do we want to break? We wanted to break here. And then we want to break, in source, TOML parser 74. So our key is fruit. That's what we expect. We peeked if we have a period, which we do. And actually, let's see what we have for tokens. So we got, yeah, this period. So we're going to eat this period. Table's empty. Oh, for Christ's sake. I am just going to make life difficult on myself. What else did I misspell? Token, closed, value, class name. All right. So what was that, 193, I think? Nope, obviously was not. It was not 194. Okay, and then TOML parser line 74. Then I want to continue. What are the chances we get anything? Guess what would help? Let's return the string. Suddenly I'm on the struggle bus. Something fierce. $75. Continue that. Okay. Unbelievable. That was incredible. You know what, actually? Because it's the same value, right? Well, we'll just see what happens, right? So we have a period, right? We went from 76 to 77, which puts us here. We eat that. It's not in the table. So we set that to the table. Now if we take a look at our meta info, it's in there. So we don't want this to be the same value. So that was a big mistake on my hand, and that's probably what's screwing everything up. So where else? So we don't want this to be the value. We want this to be another its own table. And so maybe then we set that to default of none. feel like I need to write all my files on this. Okay, so progress of some sort, I suppose. So this is test key redefinition. Maybe what we can do is we can move some of this logic into, so what we'll do is we'll actually pass that value in. I take it all back. So we pass the value in there. Okay, so here we will get the value. That's what we'll do. See what that gives us. We still have a key, test key redefinition. Where is that? 102. So what is going on? Key redefinition. I guess what's going on here is, right, we are synthesizing this fake value. Where are we doing that? But we're saying that's not okay. I suspect that's what's happening. Because, right, this assertion error is happening at 102. Yeah. So maybe instead of doing this, right, we can go ahead and go ahead and parse our values here. Well, the point of that was to sort of simplify this, because, right, we could, so what is the example here? Right, because here we get a rekey. The example that we're handling here is we get a key redefinition here at Apple, but we still have another key to parse. So what happens if right, so we get a key redefinition here, we log that, then we eat that, then we come back, we haven't actually updated table. So essentially we're ignoring that. So I do kind of like doing that, but I feel like we probably, so let's just try this. So we already know we're invalid, so we probably want to stop then. Something like that, maybe. So now if we are valid, I don't know, let's just see what that does for us. 3 errors, so we get that which is what we expected. And now our errors are that we are not passing enough things into a key value. So this is here from inline table. Hmm. I was already there. And now I can't type it. So I guess what I'm thinking is, if we get a table back here, right? Um, if we get a table back, or if we set a val, I feel like any value we explicitly set here, I guess is closed. But now the question is, what do we pass into here? So we get to here from what? Value? Maybe we need this meta info. Because right, we are setting this. Or do we just synthesize one? Do we actually need to even hang on to this? We probably do. Well, let's just try this. Let's just try this. I'm actually not sure we do, because, right, if we try and ever, like, get back in there, I think we're going to come through here. I don't know. So let's just pass in a bogus meta info. Let's just do that for now. Right, that'll get us working. What do I want to do here? I guess this will be none. This will be closed. This will be result. And we'll pass in that meta info. So let's see what happens. Our only errors that we have are error message. Or the wrong error message. So while we're at it, let's actually spiffy this up a little bit. So since we have this meta info, we can now say where it was already redefined. So what we want to do is do meta info token. So this will be value token.line token.car. And then, so we'll do meta info key. Let's see what happens there. We have two errors. Oh, not key, token. So let's see here. Does this give me any sort of stack trace? I guess it does not. Right, it just tells me on 29 we blew up. Key type has already been defined. I think I'll do on line 2, character 1, I think we're saying. And then our other error, none-type object has no, uh-oh. Well, that's no good. Oh, forgot the period. And then here, so what's going on here? Let me split this out. So 297, 107. That's happening there. Are we not passing a key? What we want here is the I believe that's what we want. Yeah, so name has already been defined on line 2, character 1. Spelling 1, 2, 3, 4, 5, 6 on line 6. Character 1 on line, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. I think that's what we're saying. 6, 1, 2, 1, what am I? Test key name has already been defined on line 2. We actually got 2. Oh, yeah. All right. Not 100% sure about all that, but guess that's why one has tests. So where are we here? We have more examples. This is also, I think this should fall into the same category as right, this is saying the same thing, but this is trying to, right, this is just the opposite of this, but this is not failing because type is closed. This is failing because we've already defined, this would theoretically completely overwrite type. I feel like I wanna so we're saying here name equals nail. And then we're saying type edible equals false. So key type is, I guess we should get the same error there. Yeah, all right. And I guess that's all our examples for inline tables. So now we go to regular table. Yeah, just table here. Okay, so I kind of feel like I'm going to want to take this step at a time. This should result in an empty table. Oh, TOML. Parse table is not defined. I did not think it would be. So we'll put that down under here. So essentially, right, this is going to update our state to set like the active table. So I suppose I should read this. Tables are collections of key value pairs. They're defined by headers with square brackets and aligned by themselves. You can tell headers apart from arrays because they are only ever values. Under that, until the next header or end of file are the key values of that table. Key value pairs within tables are not guaranteed to be in any specific order. So anyway, we're going to want to eat this token. That'll be left bracket. We're also going to want to eat the right bracket. And then this is going to be, actually we want to parse a key. Which is we're going to need to break this out from parse key value here. I guess I'm going to have to think about how that works. Well, let's work from the bottom. I know I'm going to need to break this out as a function, so let's just start with that. Parse key iterator. So let's, for the moment, just yank that. So I guess we're going to need the table, right? I guess a meta info. So, but we're going to need to get kind of like the resulting table or key and table back. So let me think about this. Table and meta info is like only, or key value is only acting on the like the active table. So I think that's all we need here. Let me just walk through this. So I'm just trying to think if there's, because right now, basically, we do need this valid. Because I'm thinking, right, I guess basically the most straightforward way to map this would be like return valid key table. This would turn into valid key table equals this, right? And I think everything's the same. And then up here, we would get, I guess, valid key table. We're going to want to pass in, I guess, the table and the meta info. Which means we're probably going to need that here. Actually, I think we want the state in here. So we're going to pass in the root state and the state meta info. We're going to get another key in a table back. And then if valid, what we're going to want to do is state that active table is going to be like that, and then state that like active meta info is going to be, oh wait, yeah, is going to be the meta info value I guess. Actually, I guess we're going to want to set I suppose it's going to look a little something. Where's maybe like that? I don't know. I guess I need to look at the rules a little bit clearer. Here, value is going to be a new table. I'm not sure what to. No, it's not going to be closed because we're going to add to this. That might need to be all we do. We're going to have like state. Okay, and then this is going to be, yeah, and that'll be that, I guess. So where's parse table here? Oh, I guess we already passed that in there. So let's see what happens. I need that. That info is not defined. What? Oh, wait. I guess that's that. Which makes that even a little bit. So that makes that a little bit gnarlier. Maybe I can just like pass that back as a result or something, like wrap that all up. In fact, having just said that, let's do that. Let's do the key. We'll do the table. Or I guess this is going to be a value. And the meta info. So self. We'll set all that. So what we'll do is a valid. So if valid, then we'll return key result with the key, the table, and the meta info in there. Else return none. I guess that's actually not, we know that's going to be a table. Okay, and then where are we here? First key. We'll have key equals that. So if key maybe result. I guess I gotta think. not in so then we set the value. Actually, this is just to result that key. Suppose that ends up not being any cleaner. But then okay. So I guess that is that. So that gives us just our first basic example there. So let's do these. So we're gonna have table 1 is gonna be key 1 is some string. Key 2 is 1, 2, 3. So that didn't work, but okay. Oh, we got a so key 1 was redefined somewhere apparently. I suspect that's because this is going to be active table and I think oh yeah. Okay. And then let's do this. I think that's that. Yep. Then we're gonna have all these. So A is going to be a table to B, a table to C. Oops. And then B, E, F, G, H, I, and this I'm going to have to copy. think that should all pass. 100. Missing closing bracket for table. Front row. Why do we think we're missing a closing bracket for a table? I delete something I was not supposed to. Missing closing bracket for table. Huh. That is breaking in the Lexer. Well, that's right. That is throwing an assertion error that the framework is capturing. So I guess I just gotta break on it. Um, so why do we think GH I feel like oh, this is not. So we do eat the white space here. So let's walk through this here. 60. So we eat that. Uh, we did not Lex all the way to the end for some reason. Eat white space. We didn't get past that period. Why didn't I get past the period? So we eat the white space. We have in tokens H. Um, you've got to eat. You've got to eat after that too. Right? We are on a key. We elect that key. We eat the white space. Um, which I kind of feel like I don't like. So parse. What if we do this? Parsing equals true. While parsing. We want Alexa key and eat space. Then if p character is that, then we want to do that and eat white space. Otherwise, parsing equals false. Right, we eat it, we slap it on, we eat the white space, we're back. So let's try that. Okay, dope. So those are all our examples here. But now we gotta throw these in here, I suppose. Um, so let's check this out. So we have X. Y. Z. W. And you know what, let's just do that. So this will slap that in here. Okay. Empty tables are allowed, and you simply have no key value pairs with them. Like keys, you cannot define a table more than once. So what do I have in my tests for? I don't think we're catching this. And I have redefinition. I am unable to spell redefinition, apparently. So we're going to throw new tests in here. Means I'm gonna have to spell redefinition again. What is it, by the way? Jeez, it's getting late. Sorry, I need to text I need to answer here. All right. So okay, so this should give us an error. So we're gonna get what? 1, 2, 3, 4, 5, 6, 2. Um, so there's no way I'm handling this, but on the off chance I am, yeah, we're just rewriting to that. So I think we need a new thing here. Basically anything that's explicitly defined. So what we're going to need here is this is going to be true. True. That's going to be false. Right? No, that's going to be true. And this is going to be false. And I guess that'll be true, true, I guess. I don't think it matters what we put in there, but we'll put in true. Not sure. Not sure. If everything blows up, yeah, that probably needs to be false then. I guess? I don't know. Actually, that should not have mattered. Oh, I just... Boy, I don't know what I'm typing. Okay. So, where are we here? So, think that's all we need. I have a feeling this is not going to be right. No. I guess, that's going to be, I feel like that's going to be false. Didn't fix anything. Well, so let's, what is this, table redefinition? Let's go here. Let's just break on 663, run, okay. So we're going to parse the table here. So now we want to break on on 90. So what do we have for result? Of course, I didn't. Well, we got a thing back. So we got fruit, right? I suppose it would help. So we got fruit back. This should be the first one. What do we want? We want table. Should be an empty table. Oh, of course I did not. That's self.explicit. Where am I here? I guess it doesn't matter. And where are we at here? Let's break on 662. Maybe not. Let's break on 661. What was that? 96. No, 95. Of course, we don't want that now. 95. So key is fruit. Table should be empty. And of course I have a fucking error in my... What's the problem here now? God. So is it test? Why didn't that stop? I guess that did. $95. Okay, we actually have... Okay, key... So it's not, right? So, all right. We have fruit. We have fruit. Where the hell am I stopped here? So if value is not in table, otherwise I guess we want this, I guess that's what we want. That did not work at all. What was my meta info up here? Oh, exiting debugger cleared my console. It looks like. Meta info, that's a token. Explicit was true. I guess maybe just to make this a little bit easier. I don't know. But we need to check the meta info of so what is this doing? This is setting, yeah, let's do this. Let's do that's explicit. Otherwise, we'll do this. Okay, and we just got the wrong message now, it looks like. I think. One, two, three, four, five. Yeah, we can't do that because we pull, right, we set that to true and immediately pull that out again. So that was a huge mistake. Elif, I don't know, I guess for the moment. Okay, and so now we just have our one failure. We're saying key fruit, right? Character 2. Okay. Well, I may have to do array tables another day because this is dragging out and it's getting late. And I need to do other things tonight still. um, so let's do vegetable. Celery equals green. Vegetable dot celery. I don't know. Let's do rib. So what's the problem here? This is redefining an apple as a table when we already said it was just a string. So I think we should catch that already. We do in a sense, in that we crash horribly. So table is what? So let's comment this first. that'll be 671. And let's break here. What is that, 123? In this case, we should not, now what we want is, we want table. So that's fine. And what do we have? We've got vegetable. It was explicitly defined. Okay, so let's continue. So now keys again, it's texture. So we got green back, right? And what's our meta info? So I think it's like if type table is not thick, then this is going to be that. This is, I think, just going to be the meta info. And let's do this. Oh. Wait, what was this before? Oh, this is happening somewhere else. What? Meta info object has no attribute line. Oh, this is the wait. Yeah, I gotta add this error in. So key, so what's the problem here? Seller, I believe. Online, we're calling this what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Character 1. And this is going to be, let's see, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 12, I believe. Key seller, we actually has already been defined on line 1, character 1. Oh, and we got texture? line. So what's happening here? We are it must be something here. Let's just print this out real quick. And then what's going on here? Oh great. Well, where do we have a failure here? Are we really not? Texture. We're looking for texture. Um, Setting active table to green. Table with key celery already exists. Setting active table to green. explicit is true, closed is true. All right, so now we come down here into keyval. I guess this is what's happening. That's not where it's happening. Because, right, vegetable is not closed. So it's happening up here. Uh, not a table. So what is the meta info in that case? So why are we getting... What's happening down here? So I'm getting back... Where are we here? Key file equals none. So in this case, vegetable is in table. So we skip that. We pull out vegetable. And we pull out the meta info for vegetable. And we're fine. So then we eat... right, what do we do here? We ate this period. So we pull out celery. Or no, wait. No, there is no. So there is no period, right? Right, so then it's fine. Okay, so then we eat the equal and we get the value back. So The key is celery, or texture. The table is going to be green. And the meta info is going to be the meta info for celery. So we're catching this in the wrong place. We are catching this, right, because what we're trying to do is implicitly define something that's already been, so the error I believe is down here. Oops. Well, dang, that's not what I wanted to do. Oops. Well, now Cinnamon's going to start trying to help me out. Stop trying to help me. Although arguably I need lots of help. So let's see, source bin activate. So, what am I trying to do? I'm trying to make tests here. So key. So we actually got vegetable. We expect to get celery. Am I even reading this correctly? So empty tables are allowed and simply like keys, you cannot define a table more than once. So we have fruit and fruit. So is that what we expect? Key vegetable? I guess that's right. I guess that's actually right. No, not there. We want that there. Want that there. So we got vegetable was defined on. Are there more examples here? Let's see. See, this is not the right error, I don't think. Okay, so the problem is not that we're not catching that. We are catching that. So I guess what's actually going to appear, so it's actually, the problem is here on parse table. So if we get nothing back, well, that does seem wrong, doesn't it? So why are we getting something back? Valid equals true. Guess I just have to step in here. Although before I do that, so we're going to comment that out. And then, so we want to break on test 672. So let's break here in parse table. We're going to break, let's break on 95. I guess I should look to see, well, we did get something back per result. So this is the first time we're in here, right? I guess this is why having that split was nice. All right, so key should be vegetable. We should have an empty table back. And our meta info should be yeah, I guess the meta info of the table we're going to stick it in of the table we're going to stick it into. So in this case, it doesn't exist. All right. And actually, I suppose that probably let's actually break. That's on 91. Sorry, let's just step through this. We set, yeah, we're setting the value to a new empty table. We basically create a new empty table, set that to the value, and then set the meta info for that value. And then we pull that out and set that to the active table and the active meta info. So then we're going to go through keyval. So now we're back here. We have, well, state is not going to be, root. Yeah, so, okay. We're going to eat that left bracket. Then we're going to parse this key. So we're valid. What do we get back? We get back vegetable. And then we will have a period. So, right, we went from 139 to 140. So we eat that. And what do we have in table? Vegetable's already in table, right? We said our key is vegetable. So we pull the table out, and we pull the meta info out. So our table is now just going to be celery is green, and the meta info is going to be for the vegetable. I feel like we're not looking at the right meta info. And this is like, um, kind of what I feel like. Because right, we're checking the meta info of celery of vegetable here. Chris, now we've got hmm. Uh, what are we, 150 here? So that is breaking everything. So oh well, it would help if I was. Having a hard time with this one, and the thing that's killing me is I had this figured out before, so maybe I'm just too tired. So let's see what we're doing here with so this meta info applies to this table, right? And when we set those to the active meta info, I just kind of feel like we're getting back the wrong meta info here. So when we start parsing, well, we just pass that state in. So, right, we should have the info for that table. I guess I should undo whatever I did to break everything here. So we're creating a table under vegetable. So that's going to be an empty table, and we're setting meta info, yeah, for vegetable. So table celery already exists, so we set the active table to green. and that is the meta info for celery. So that's correct. I feel like something needs to happen down here. Well, we're saying we're going to set a key in this table. So, right, we get this back. So first of all, this table is not even a dictionary. So is this basically the logic we need to, so if it is not a dictionary, I'm gonna have to walk through this again. Where are we here? So we're there. Now I want to break on a parse table. So is that 91? So let's continue. So let's just be sure what we have here. We've got key celery and then the closing bracket, right? So we have this, and then we're gonna have, or not celery, vegetable. The new line, and then celery equals green. So, okay. Eat that. We have a result, right? So key is vegetable, table's an empty table, and the meta info. Right, yeah, we're setting vegetable in this table, and we're setting it in the root table. So this is the meta info for the root table. So there's 9 on the table. We create the value, set that, then create a meta info for this table that we just created. Then set those to the active table, the meta info. So back here, when we go through the key val, we're updating the vegetable table, not the root table. Okay, so that makes sense. So when we come back in here, right? What is it? State. Yep, is green. And actually, we can look at, right? So vegetable, celery, green, but the active table, celery, green. So yeah, but the all right, yeah, that's right. This is the root meta, and this is okay. So that looks fine. So where did we stop here? Continue. It came down to eat token. So we do want to eat that token. Then we want to step into parse key, and we're going off the root table and the meta info. So parse the key, return valid. We eat the token. And we're going to have a period, right? Yes. So period is on 139. Next, we should go to 140. Yep. So we eat that. And vegetable is in, right? Keys vegetable. Vegetable is in the table. So we pull the vegetable table out, and then we pull the meta info out. So table now is a vegetable table, and meta info is a meta info for vegetable. So we explicitly created that here, but it's not closed because we define that as a table. And so where did we stop? So it is not closed, and it is a dictionary. All right, our table is a dictionary. So we're good. And we eat that key. There's a couple reasons I'm building it. One, yeah, TOML has been added to the Python like version 3.11, which is the very newest version. And our version at work is 3.5 right now. But also I want to build this because there's a couple things I want to do with this that I don't think the standard library does. First, I want to catch more than one error. Then also, I think once I get this, I'm probably going to want to return meta information about where keys were defined because, so this is kind of a project related to work that I'm doing. So we have TOML files that we're parsing, but not only does the TOML file itself need to be valid TOML, we need to look to see what is in the TOML file itself, because that then needs to be validated. And so I want to use the meta information that I got from parsing a TOML file to then also use that to display errors if there's errors in how they've defined their TOML file, if that makes sense. Also, welcome. Thanks for dropping in. How you doing, Typus? In fact, if I could get this working, I'm really wrapped around the wheel on this. I could probably show you, well, actually, here in my tests, so you can see I'm like logging more than one error, or I'm expecting more than one error, because I have this commented out because I'm trying to figure this one out. Oh, yeah. Yeah, I hear you on that. Sometimes it's a good time to take a nap as well, you know? So where am I? We're going to eat this key. And now I've got the celery key. And this is the problem key. But we don't have a period, so we're going to break out of our loop, right? In fact, we did break out of our loop. Uh, yeah. So we are valid. So now what happens back here? We get a valid key back. Which we should not get back. So we need to do an additional check down here. Basically, if we're valid, and I guess we want to look. I feel like this is going to look very similar to here. Except this we're not even checking. This we're not even checking the meta info, which I may have to do later. I'm not sure about this. So this check we've already done here. If type table is not a dictionary, so what are we saying here? Type of table is a dictionary. Will this just do it? What do we have for, so our key is what? Is celery. And yeah, basically we want this, I guess. So did I actually get this working now? Oops. No, nope. In fact, I broke a bunch of stuff elsewhere, I guess. I guess it's not that it's in there. Chris, because I quit the debugger, right? I lost my debugging information. So so do I need another check here? If it's in the table, I want to say close, but I don't think it's right. probably explicit. Still haven't fixed it. Or do I just have the wrong... We actually got line 2, character 1? Is that just me? This... One, two, three, four, 5, 6, 7, 8, 9, 10, 11. Yeah, no, that's not right at all. So we're getting the wrong... What are we passing in? Not sure why we're getting that. Okay. Back into the debugger yet again. Uh, 672. Where are we here? We are... It's 91, I guess? Yeah. 91. So... Right, okay. We'll just continue the next one. We want to step in here. Got a period, you want to eat that. Now our key, right? Is vegetable. So where did I stop here? The key is not, so it's not on table, so we pull out the table, we pull out the meta info. This is all good, right? Vegetables not closed. So we're fine. So we eat the token. Now we have celery out, right? Don't have a period, so we drop out. So we're valid. So what do we have? We have vegetable, we have that, and we have our meta info. So celery is in the table. And oh, we are saying it's... Oh, yes. Ugh. Yeah, I got it. All right. I think the problem here is not that it's closed, but that it's explicit. But then to get my tests to actually pass, I need to uncomment all this other code. Because I actually commented out the Python code, not the TOML code. All right, and now I've got to just take out all my prints. And of course I am still failing. Now why am I failing? So what's going on here? We actually got 11, 2. We got vegetable back. Because it's closed. All right, I was right the first time. Okay. Well, there we go. That was easy. That was about as easy as it gets, you know? Good gracious. All right. Uh, so I don't think this actually matters at all, but I'm gonna just stick this in here because I can. I guess I probably need to add that to my thing here. So we're gonna have table fruit, and then we're gonna have table apple, which will be an empty table, and we'll have table orange, which will be an empty table, and then we're gonna have animal, which is an empty table. Actually passes. I feel like that should go under dotted keys. Let's just try this again, or not again, but so our expected result here is we're gonna have name, Fido, breed, pug, owner, that's gonna be name, Regina Dogman, member since, oh great, that's, just throw this on a new line, I guess. What is this doing? Stop it. Date time, that's gonna be what, a date. Oh, that's right. I don't have this underscored in my test, so okay. And then I think this last test here, yeah, I'm not sure why this is under tables. I feel like this should be under dotted keys. So let's do that. So this is going to add what? Apple, and we're going to have color is red, and then this is going to have taste. Sweet is true. Okay, and then there are a couple things here where I had stuff commented out. Where was this? Here. Don't think that should change anything, but okay. I think that's all my table examples. Wait a minute, or is it? No, I got this. I don't know, I kind of want to... Um, fruit. That's going to be apple. Color's red. I don't know. This. Sweet is true. And texture, smooth is true. I think that's what we're saying. Yeah, all right. Okay, so the last thing that leaves us is array tables, and that is not happening tonight. I don't even want to know how long I thought I worked at trying to get this stupid thing working. But sometimes that's what happens. Sometimes that is what happens. All right, well, I don't know if anybody's still lurking. Type us if you're still lurking. But if anybody is, then I appreciate you hanging out. And yeah, until next time, I bid you peace and take care. See ya.